we go. So reviewing back, I want to just make sure you know your syllabus is in here. So this is why I'm saying I'm not exactly sure how far we'll get. I'll finish number 1 and I'll get into number 2. I can almost guarantee I won't get to the bottom here, which says one-sided and absolute value. Problem is, this little set you got, I don't know where those problems show up. So in the homework, if there's a piecewise function, you can eliminate and just put that off to the side for now. If there is an absolute value function, you can skip that for now. You'll probably end up doing that tomorrow, okay? All right, so reviewing back what we did, we started off by looking at graphically what the f prime does. And if you remember, I want to just mention a few things for you. Remember we talked about the tangent? And then if we say the slope of the tangent line, that was the same exact thing as saying f prime at that number. And in case I've never used the word, all of this is exactly the same as the word derivative. So I may or may not have said the word. So instead of saying the slope of the tangent line at x equal to 5, I will now say the derivative at x equal to 5. Have we learned how to do the slope of the tangent? Therefore, have you already learned derivative? Yeah, I'm just giving you a new vocab word. And from now on, that's the word you'll hear. You still got to know the other words. Slope of the tangent line, what kind of rate of change is that? Instantaneous rate of change. Good. All right. So then we also talked about the difference between, and we didn't necessarily talk exactly about it, but if I put a point here, and let's call that point A. So the y value would be f of A. First of all, let's start off with f of A. Put your thumb up if you think it's positive. Put your thumb down if you think it's negative. If you think it's 0, no thumbs. And if you think it's undefined, to the side. So all I'm asking is f of A. F of A. So that is this guy right here, f of A. Oh, my pen. Bert. So what is f of A? What's another way we could say f of A? Y value. All right. So then I'm going to restate the exact same question. What is the y value? Same question as I asked before. Positive, negative, 0, undefined. Put your thumbs. I want to see if anyone changed their thumbs. All right. So we know that the y value is positive because some of you, when you heard f of A, put down negative. F of A, y value, same thing. Next question is, remember, slope of the tangent line is f prime of A. Now I want to know f prime of A. Is it positive, negative, 0, undefined? Okay, thumbs. All right. Therefore, Andrew, I see you looking around. What do you think? Why? To the left of the y-axis. How many agree with Andrew? Everyone's just going to leave him hanging? Really? Why? Let me hear. I want a reason if you're just going to leave him behind like that. Khalid. I hear you, but Andrew needs to hear you. Say it again to Andrew. Do you, number one, understand what he said? I don't know, now you're asking me questions. I asked you a question. I'm not going to answer your question. So, your question was if the f prime of A is positive or negative. You originally said that it was negative, positive? I can't remember. You said it was negative because it was to the left of the y-axis. That's okay. The slope of the tangent is negative. So my question was f prime of A. And your answer now is why? Because the function is decreasing. So I will take your answer. Thank you, Khalid. It starts to get a little confusing because now I'm going to ask you about the y value, but I'm going to call it f of x. And then I'm going to talk to you about the slope of the tangent line, and we're going to call that f primed of x. And it does get extremely confusing going back and forth. And that's what this whole class is about, going back and forth. So, little things we talked about, when you do a sign chart, you're always thinking of the same type of values, positive values and negative values. But what you always look for first are zeros and undefineds. Can someone tell me on f of x, what's the word that I made you guys put right next to where it says f of x? Y values. Okay. Can someone tell me, how do I know if the y values on this graph are 0? Easy question, but I would still like to know. Isaiah. If the value hits the x-axis. Correct. Perfect. All right. Well, then I'm going to switch down and say, what's the word that we put next to f prime of x? Slopes. Okay. So this is slopes. Can someone tell me how I know that f primed of x will have a 0? Someone other than Isaiah. Someone that looks extra tired. Douglas. Horizontal tangents. I'm so happy you used that word because that is literally the word you want to keep in mind for a slope of 0. Horizontal tangent. You saw that all over your test. Horizontal tangents. So the number 0 changes. The definition of it kind of changes. You have to understand what you're looking for. Okay? So for your y values, if you're asked to do a sign chart, we always start with the same thing. I start with zeros, then I go to undefineds, and then I do my plus and minuses. That's for any sign chart that I make. There will be a point where you will have 3 sign charts for one graph. Literally 3. So you got to be really clear. Things I want you to be clear about. Here's a number 1 great example. Label your sign chart. You see that f of x? That's because the top line is going to be for f of x. And so what you guys already have down that I want to make sure we remember, because that was what? Tuesday? We took all of the y values being 0, x-axis, all the x-intercepts. Any more? No. And then we looked at if the y values were positive or negative because we found that there were no undefined y values. Me here, give me one way to have an undefined y value. If you have a discontinuity. So then, Andy, give me a type of discontinuity. A removable discontinuity. Give me another one. Infinite discontinuity. Adriana, give me another one. Oscillating. Jitesh, you listen enough to remember which one's missing? Good job. Jump. All right, so we have none of those. That means there's going to be no u's on top of my y values. And then the y values being above the x-axis mean they're positive. Y values below the x-axis mean they're negative. And above the x-axis are positive. And then I did things like this. You can put 1 plus. You can put a lot of pluses. I don't really care. I just want to make sure you know that they're pluses. So then we did the second graph, and we said slopes. So same order. When are my slopes 0? You guys already told me. All of our horizontal tangents. We got one here, we got one here, and we got one here. 0, 0. When are my slopes undefined? There's only one on the graph. Yes, Maggie? Vertical tangent line. So the tangent line happens to be up and down. So that right there finally gives us an undefined. Okay? All right. How do I know if I'm going to write a plus? Well, my slopes must be a positive, which means, what did we summarize that as? Slopes being positive means the function is doing what? Increasing. All right, gotcha. So increasing were my blues. Blue, 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 more blue. The reds were negatives, negatives, and more negatives. Okay? Summary of pretty much everything you guys did. All right? Now, given that you had some stuff that we are going to now take notes on. Notation. We talked about it already. We talked about f prime of x. That's the same exact thing as, so in this box we're literally writing the same thing as the slope of the tangent line. I feel bad for period 5. They're just going to be staring up here with no one. All right. Second thing, the other word you learned was the word derivative. So they mean the same exact thing. F primed of A is one way to write it, and you'll see that probably more often in the beginning. But then you'll also start seeing this. that also means derivative. I'm going to teach you how to read both of them. I'm not going to write them down. You can write down in the tiny little space you got. All right, f prime, we know that one. The other one, literally that says, the first D says derivative. This says derivative of y, and then the bottom part, with respect to. That piece, that other D actually in a way means with respect to x. It's kind of like a function. We call functions f of x because f is in respect to the variable x. Same thing, okay? So those are notations. You'll see them all around. So then approximating the slope of a curve at a point. This was the piece of the homework I said you didn't need to do, you didn't need to approximate. Well, essentially what we're going to do is we're going to pick some x values. Okay? I believe I already put them on for you so that we all would have the same ones. So if I pick the x value here, it's 0, and the easier one to answer is f of x. Well, that's just the y value. And if you're having trouble with this, you'll write the word y value in front of f of x. And then you're going to find the slope there. Well, what's the slope, which is f primed of x? What's the slope at that point? It's a line, therefore, what's the easiest way? Rise over run. So I'm going to rise down, I guess. 1, 2, and then run 1 over. So it is negative 2. The values are different. Okay? Then I pick the other value up here, which actually moved by accident. We'll pick this one. Sorry about that. Little guy moved. Up there, the x value is negative 2. My y value is how much for that guy? 5. Good job. And then my slope is negative 2. Question for you. Linear function. No matter where I put the point, what do you notice about the derivative? It'll be the same. Why? Because it's a line. Great answer, guys. Because lines have... All right, that constant slope is what you guys are saying, and that's what we're looking for. All right, so second guy. We'll go left to right. So this one first. X is 0. My y value is negative 3. And then right there, this is the problem. Now it's going to start to curve a little bit. But this one doesn't look too bad. It looks kind of straight, kind of. So what you're going to do, you're going to draw yourself a tangent line. Remember how we draw them? You want it to look like it's balanced on both sides of the point. Do you guys see that little mini angle and that mini angle? They look like vertical angles. That's what you're looking for. All right, now that I have that, what you're going to do is extend it until it looks like it's hitting some points that you can actually count. What do I mean by that? If I labeled this point right here, would you know what the x and y value are? No, so we're not going to use that one. Now, if you want to use this one because you say, oh, it kind of looks like it's halfway in between, so I'm going to use 1/2 comma negative 1. That works for me. That's fine. Maybe it's 0.45. But if I'm asking you to guesstimate, I just need it to look like it makes sense. Will everyone's answers be exactly the same? No, that's okay, as long as your line matches up with your answer. So I'm going to use, in a different color, I'm going to use this red point, which is now blue, and I'm going to use, I guess, the one up here, because that looks like it's kind of. This side I curved a little bit, which is why it didn't work, but that would be another point I probably could have used. If yours is different, then you use a different point. If none of them ever touch a nice number, then you're going to guesstimate, and that's okay too. All right, so for this guy, from the y-intercept, I'm going up 1, 2, 3, 4. I'm going right 1, so that guy's slope would be a positive 4. You're literally drawing your tangent line, finding its slope, but it might be a little bit of a guess. It might not be perfect. That one worked out nice. The middle one's going to work out extra nice for us because the y value at x equal to 2, what do you guys get? Positive 1, and then the slope there is right here. How much? 0. I should hear all of you yelling out that one. That's an easy one, right? All right. So then this guy right here, we'll do that in bright green. So you just extend and you try your best to guesstimate the slope. Is it perfect? Probably not. If you use a ruler, will it be better? Yes. So on a test, you'll definitely use a ruler for your notes. Right now, if it's a little crooked, that's fine. But you would pick any 2 points that you think you can kind of figure out the values. So I'll pick that one. Not perfect, but it would work. Does it make sense on what it means to approximate the slope using a grid? I gave you a grid and you can count it. Does that make sense to you, all of you? Can I see a thumbs up if you're good? Okay. Alrighty. So that's the last piece of the homework that I asked you not to do at the time, because I wanted you to at least see the tangent lines. You guys can find the slope of any line. Rise over run. It's kind of weird when you're making your own line and it might not be perfect. And that's what I want you to understand. Your answers can be different. Say that one more time for this guy, the green one. Down 1 over, yep, -2. Adriana? For this problem, yes, your slopes even within your groups may be different. And it all depends on if your tangent line is drawn exactly the same. Now, if Douglas gets -2 and you give me +1, there's no way that that's right. One of you has to be wrong because one of them positive, one of them negative makes no sense. The graph is decreasing, so that would tell me Douglas is right and that yours, maybe you forgot the negative. And then I would look at your line and say, your 2 points, does it look like the slope is -1? And that's what I look at. Does that make sense? The point. Great question. She said, do you have to use the point that at where we're doing it? I would always use that to start. Always. Okay? All right. Are we good to move on? Yes? I would first look to see on a test if your tangent line looks right, because you can draw a wrong tangent line. If your tangent line is right, then yes, I look at your tangent line and see your points, and then I look at your answer. If your tangent line is wrong, I still look at your tangent line and your points. So if your tangent line's wrong, but your points on there plus the slope are correct to that line, then you get partial credit. That's that FT that you might see. FT means follow through. I take off a point somewhere. You still have the wrong answer, so I have to cross it out. But I at least give you all the points that went along with some work that you did that was right based off a wrong answer. Good? Okay, Courtney? There's a lot of them. That's wrong. That's wrong. That's wrong. And yes, I do see all of them. It happens. You know why? I figured it took me a really long time to figure out how possibly, after my whole description of the seesaw and balancing and vertical angles, all that type of stuff, it's because that particular student has blanked out through all of it, and the only time they looked and actually took anything in was when we did a normal line. That's the only time that anything made sense, was that normal line. So then every tangent line was a normal line. That's the one time. It took me years to figure that out. All right, how to create sign charts. This is just a summary because you're going to make them so often. I want to make sure that you remember the rules I write. They're the rules for any sign chart. Doesn't matter if you're making it for F or F prime. You'll hear me say F double prime. It means the slopes of the slopes. How do you, yep, you heard me say the slopes of the slopes. All right, how do you make a sign chart? First, figuring out when signs are 0. Signs undefined. And then 3 positive, negative. That's always, why did I do that? It's always the order I go in. 0, undefined, positive, negative. I just do that almost every time. So what makes sign charts so difficult? It's what makes a 0. So if you want to give yourself a little star, you can talk about f of x. We talk about y values. And then we can give a little star for f prime of x, because that's when we talk about slopes. can you make a curve where the y value is 0 and the slope is 0? You sure? I hear some yeses. I want the slope and the y value both to be 0. Is that possible? I feel like you're just answering. Yeah. Andrew? Beautiful. A y value of 0 and a slope value of 0, x squared is a perfect example, right at its vertex. Good statement. You'll hear me say the slope a lot, and at this point we are pretty much always talking about the slope of the tangent. I'll try to correct myself and finish out my sentences, okay? All right. How to graph the derivative function. This is what we did not do the other day. So, how to graph them? Well, number one, you do a sign chart. You'll hear me say it all the time. And then I'll know if you're not paying attention to me and that you're a rebel if you're trying to do work and I don't ever see sign charts, and you'll hear me say it over and over and over. It's my way of verifying that you understand. So a sign chart. And then from there, we sometimes, if you have a grid, so this is only if you have a grid, we're going to approximate for slopes using tangent lines. Sorry, you'd have to take a pass over. Take a pass over. Office. All right, so really, that whole box is honestly there for you to remember to do a sign chart. That's really all I care about, is doing a sign chart. I'm going to have to translate over what that means because it is a little bit confusing. So, let's start off by let me see what's next after this. All right, so I'm going to hold off on that for a second. I actually did this a little bit out of order from the way that I'd like to do it. So here's what we're going to do. We're going to actually graph a derivative. Okay? I'm going to show you the process in which I take to graph a derivative. You guys, the other day for homework, were asked just to simply make the sign charts. What I'm going to do is the same thing. I'm actually going to give myself a little more room. Let's see. What happened there? Okay. Oh, I don't know what that was. All right. What, really? Oh man. I think I'm forgetting to click here, huh? Oh yeah, no, it's not. Sorry. You guys don't understand. The screen here is actually different from the computer, and that's the issue. I can't actually copy and paste right now. All right, so never mind on that. It will still be here. I'm going to pull it down, though, so I have a little more room. All right, grab the door for me, please. All right, so we did the sign charts. I'm looking to do the F prime sign chart. Who do you need, Mr. Perry? Okay. All right, Courtney, honey. Someone's at the door for you? All right, so I'm actually asking you guys to do the F prime sign chart with me because that's the one we're going to need. So when we do the sign chart, remember that box where we said sign chart really big? We're going to have to add something because I'm thinking too fast here. Sign chart of F prime. Forgot that. Thinking too fast. Sign chart of F prime. And we'll probably end up writing the notes for it here, but I want to go back and finish this guy. So, first of all, you say them exactly in this order. You see F prime, what words do we write in front of F prime to help us? Slopes. So you're just going to keep saying the word slopes. So, where are the slopes 0? Nowhere at all. So will I have any tick marks on my graph or my sign chart? No. All right. Where are the slopes undefined? Nowhere. Okay, great. So then the next question is, where are my slopes positive? Everywhere. So just put everywhere positives. I always want to do one of those so you see you might not have lines. So that's the starting place. Then we're going to do the 3 values of f prime. So we'll do f prime at, let's say, -1. I want you guys to do f prime at 0. And then in this case, because it said only give 3, then we'll only give 3. F prime of 1. This one's the easy one. What do you notice? How much are all the slopes? 2. Rise 2, run 1. So they're all 2. All right, so you see this graph here? We're going to graph the derivative on top of it. I want you to pretend like that graph does not exist right now. Okay? I don't want you to think it's there. If it helps you to just graph it off to the side, you can. But I want you to pretend like the graph is not there. I am going to take red and draw the graph. So, at f prime of -1 equal to 2, how do I physically graph that? I go to -1, and I go up to 2. Then I go to 0, and I go up to 2. And then I go to 1, and I go up to 2. Do you see a pattern? So, let's draw this red line, and let's make sense of it. Here's where I confuse you. So you see here where it said f prime is plus, 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 plus. We knew that, right? How much was the slope everywhere? 2. To a positive number or a negative number? It's a positive number. That positive number correlates to these pluses. Does that make sense so far? So then the question was, we're going to make the graph of the derivative. So what it means is, if I pick a point on the curve, I pick the x value of 3. Okay? Well, let's do 2 because it's actually on the graph. Here is the y value. That's the y value. How much is it? 5. All right. Go back to that 2 and go up to the derivative curve. You see the purple? That is the slope at x equal to 2. And the y value at x equal to 2. They're different. Does it make sense? One point, it tends to make a little sense. That's why we do points to help us out. So if I pick another point, -2, the y value would have been where it hits on the y. The slope value would be the value on the red line. But we get those points from making those tangent lines every single time. I'm going to do one example before I actually take any questions so I can make sure that you can see it. I'm going to have to erase it to make it work. Let's try another one, because this is going to be different. Why was that one so easy? There's a line. All the slopes are the same. Are the slopes same here? No. So let's do 3 points. We'll do nice ones. We'll do one there. We'll do one here. I'm actually going to do 4 for this one. We are. I just wanted to label the points because you're going to do that. You're going to do that part on your own. So here's f prime. You should be making your sign chart first. And then when you're done, I want you to use those points to make your approximations for your derivative. So that's what you're doing right now. Use your table partners to help if you get a little stuck, so I should hear some conversation. Double check your sign charts with your table groups before you get moving. I heard her say a statement. I need you to correct it. She said, when the slope is undefined is at the horizontal tangent. Said something like that. Is that a true statement?
The slope is undefined. No, the slope. Oh, it's vertical.
You guys get horizontal and vertical confused all the time. Because you're messy. Get a straight edge out. It makes it a lot easier. I'm trying to find a note card for you. Yep, they will. That'll make it easier. I'm going to come around with index cards. Should have done it from the beginning. These will help you have a straight line. That's okay. Looking to see. All right, it looks like most of you guys have your sign chart. So let's just make sure, confirm. Were there any places where the derivative, the slope of the tangent line, the instantaneous rate of change, f prime, all meaning the same thing, was there any place that it was 0? Yes, where? At x equal to 0. So this is where you'll start to actually write some values. The bottom, I write my x values always. It's the same way that I do a sign chart every single time you'll see it. On top of it, I write the prime values, the f prime values on top. Were there any places where the slope was undefined? No. Okay. Were there any places where the slope was positive? Yes. Where? Right, I hope. Okay. Negative? To the left of 0. Okay. Anyone having issues, concerns? Okay. Next thing you guys needed to do, and yours will be neater than mine, you had to do tangent lines. So this one's my easy one, so I'm going to cheat and do that one first. The other ones, we might be a little different. That's okay. So I think that this one kind of looks like maybe that. So my guess would be I'm a little bit off, so I would think it looks like -4. About. All right. First thing I'm going to check that if you said the slope was negative to the left here, where it says minus sign, then you better have a negative answer where it says f prime of -2. They should match. All right, then to the right, I think this guy, 1.8, or maybe some of you have 2. 2 works for me. And then this one, I think is probably, if you use -4, my guess is you probably have something close to 4 again. If you had -3.8, you probably have something close. Does it make sense because of the way that graph works out? Does that make sense? All right, what's special about the graph that makes that 4 and -4 happen? Because it's a parabola. I know it's a parabola, but what about a parabola? Janet, what about a parabola might make that 4 and -4 happen? I can repeat it again. So at -2 and +2, this slope is -4, this slope is +4. This slope is +2. What do you guys think would be the slope over here? -2. Why? I'll give you a hint. I'll give you a hint. Look at the graph. What's special about the graph? It's not an absolute value. It's symmetric about the y-axis, even or odd. Even. Remember that definition, right? Symmetric about the y-axis means even. That's why it's happening. That helps a little bit, okay? Now we're going to make the graph, okay? So now you're going to say, oh my God, how am I going to put this on there? Pick up a colored pencil. Use something different so you can see it better, all right? Because does your graph look crazy with like 30 million lines right now? Yes, that's what it should look like. It should look like that right now. So I'm totally going to cheat, and I'm going to do this. You will take out a different color. But you'll notice we don't need it anyway. So at -2, -4 wouldn't fit. At 0, it's 0. At 1, it's 2. At 2, it's 4. What do you think's happening at 3? Probably 6. At 4, it's probably 8. Do we know that for a fact? No. But I'm assuming you kind of see it, and then now I want you to graph it, and then we're going to talk about it. Now we're going to talk about it, because now you got to understand, what did you just draw? Because now things are confusing. You drew the derivative, so first thing, label it. That's f prime of x. You drew the derivative. Second thing, how does the derivative work? Someone want to tell me, how does the derivative work? So let's do something that we didn't use. So I'm going to pick 2.5 as my x value. Can someone describe to me what that purple graph represents when I pick the value of x equal to 2.5? I am going to pick someone who hasn't spoken yet. Samaya. Oh, goodness. Is that what you just said? Oh, goodness. Did you? Eye contact? The question is, when I say x equal to 2.5, what does this purple graph represent, and how would I use it? It is the slope. So what does that mean? It is f prime of x. F prime of x equals, and I wanted it at 2.5, right? All right. Could you actually fill out that statement? F prime of 2.5? You have 5.5? I think I have probably just 5. Okay, you filled out a true statement. Samiza, what does her true statement mean? F prime of 2.5 equals 5. I like that. At the x value of 2.5, the y value, the purple y value, is 5. Michelle, can you tell me what it means with the blue graph? Because Samiza gave us that the purple graph has a y value of 2.5. What does it mean for the blue graph? This number, what does that mean for the blue graph? That's a little bit, in my opinion, a little bit harder of a question. You can tag a member of this class if you'd like some help. Gustavo, honey. Say it louder. The slope at that point. So let me go find the point, because it's barely on my graph. Let's use bright green so it's noticeable. So what did I pick? 2.5. It'd be about here. You're telling me that if I drew a hopefully good-looking tangent line, what are you telling me about my green line? That the slope is 5. So let me repeat exactly what just happened. Samiza told us that if I'm looking at the purple f prime graph, she told me that it will then tell us that at 2.5, f prime of 2.5 is 5. That makes sense to everyone, right? We looked at the physical y value on the purple graph, which is a little weird. But then Gustavo told me at 2.5, if I draw the point on the curve, the blue curve, if I make its slope, then that is also 5. Is that a true statement? About maybe not perfect? Let's try another point and then we'll summarize it together. All right, so let's pick negative 1.5 is my x value. I'm going to go the other way. I'm going to go the way that you've been doing your problems. Does it make sense that if I wanted to find f prime of negative 1.5, instead of using the y value of the derivative, I can go up to the curve. It might not be perfect, but somewhere up there. Does it make sense to draw my slope? All right. I don't exactly know how much it will be. About 2, about 3. I don't know. It's not perfect. So that is down 1 over a half, right? Does that make sense? Down 1 over a half. That's about negative 2, about. Not perfect. So about negative 2. So what does f prime of negative 1.5 mean? What is that question asking you, Isaiah? On which graph? On the blue f of x graph, it's telling us the slope of it. What it's doing on the purple graph is just the y value of the purple graph. All the y values of your purple graph give you slopes. It's kind of crazy. You think it's easy, but it is confusing. It's a confusing thing. Courtney. Graph. Perfect summary. The purple graph are the slopes. They are the values of the slopes. The way you find them is by making tangent lines on the original graph. That is a perfect summary. Perfect. When we do a sign chart, what do you look for first? Zeros. Then. Undefined. Then. And then. Okay. I'm changing the homework. It is only number 1. You're finishing it completely now. If there's anything that you're a little bit stuck on, because there are probably 1 or 2 things that I'm not really comfortable releasing you for just yet, and I'll tell you what it is. It's going to be trying to graph derivatives. I'm not really comfortable with you guys graphing full derivatives yet. We're going to talk about that at the beginning of class tomorrow, along with many other things, because I'm not getting through anything. Samita? Yeah, if I want you to try, okay? All right, see you guys. Yes.